disruption, amazing aurora, continued for a long time. In the more recent past, these coronal mass ejections have caused power outages and other kinds of disruptions. And the most important thing we have to understand is that our society today is far, far more susceptible to these coronal events than it was in 1859. I mean, we may have had telegraphs, but think of what we have now that's susceptible to this kind of interruption, like our satellites.
David, we're looking at Blackwell, Missouri, where there is totality. Just explain for viewers exactly what they're seeing. Obviously, the moon is now moved in front of the sun from our vantage point. But right. The corona that you're speaking of, that is what is coming off the sun all around.
Right. You're looking at the structure of the inner corona. That is the you might consider it the outer atmosphere of the sun. You know, when you look at the sun's a great glow of glowing gas. It's not a solid surface, and that technically is an atmosphere. But that atmosphere continues out millions of miles into space, and we can only see it in this kind of an eclipse when the great brilliance of the surface, I should say visible surface of the sun, is blocked out. And you know why that occurs? I mean, the moon itself doesn't give off any light at all. You know, people ask, well, gee, you know, when the full moon looks real bright, well, yeah, the full moon is something you see because the sun is shining on it. But when the moon is between the Earth and the sun, that shiny face is facing away from us, and we have the night side that we are seeing blocking out the light of the sun.
So, David, just from a science standpoint, what are our scientists right now looking at? I mean, as we're watching this image from Blackwell in totality at 1:18 p.m. Central Time, what would scientists be looking at?
The big question is, what causes how does energy transfer from the sun itself, from the photosphere and from inside the photosphere, out into that chromospheric area? And how is it transferred, and what are the physical processes that take place in there? And we want to be able to see as precisely as possible what triggers these flares, these explosions. And if we can get an idea of what triggers them, then we can get more of a predictive mechanism for determining the existence of what Chris